And welcome, everyone. This is Debbie Mayberry with National Kitchen and Bath Association. You're here for our very first webinar of the month on sustainable design and living. This is the Vision House Seattle Cascades, and as you can see here on the screen, form and function. And our presenters today are, let me just tell you who they are, C.R. Herro, who's the VP of Innovation for Meritage Homes, and Stace McGee, who's the co-founder and principal of Equiterra Regenerative Design. And I'm going to turn this over to both of them, and I want to thank you for being here. Okay, CR, let me just unmute your line here for a second. And
perfect.
Thank you.
So good afternoon, or whatever time it is that you are watching the recording of this. This is CR Herro. I'm glad I'm doing this on April 1st because as a biologist, chemist, and engineer, this is the only day of the year I should be talking about design. Luckily, with me, I have Stace McGee, who is the architect for this project, who is an expert at this, who can fill in all of the dumb things that I will say for the next hour. So good morning, Stace.
Good morning, CR. And you don't say dumb things. You actually do a great job.
Oh, I pay you
a good day.
A lot to say those nice things. So before we get started, I do want to thank Geberit for sponsoring this. I always love, and this whole project is all about assembling a team of experts in order to execute a new standard for form and function. And that's what we wanted to talk a little bit about today, and looking at the opportunities to build a better home. If those of you who are on the call are interested in following the expanded story, there is a tremendous amount of information on a microsite hosted by Green Builder Media for the Vision House Seattle Cascades. Please do join us there. So I'm going to start as a building scientist with a little bit of an overview on why we thought it was important to build a home that represented a new call to action. And as a building scientist, one of the major things that drive a lot of the innovation happening over the last 10 years has been an awareness and a growing awareness by our consumers that we participate very actively in our climate, in our global ecosystem. And not only do we participate in affecting it, but as we affect it, climate change is then placing new challenges and therefore opportunities on the form and function of the homes that we design and live in. And changes to weather patterns, hotter hots, colder colds, drier dries, wetter wets, all of this is creating a need to think about resiliency in our design standard, but also to make sure that we do not lose form in order to drive function. And that's the discipline that I'm super proud to have Stace along for this ride for the last couple of years with, is because it's really important that as we, as building scientists, address the challenges of the future, that we keep foremost in mind the lives of the families that will live in these homes. Thoughts, Stace?
Yeah, I do definitely have. So during today's presentation, I'm going to try to give us a design perspective, and I would imagine we have a lot of designers on the line, both architects, interior designers, and just designers. And as a designer, I actually grew up in Florida, and I have watched these weather patterns change and our hurricanes go places that they never went before. And over the years, very much been involved in what we called environmental design, eco-design. It became sustainable design, regenerative design. But right now, really, I think that we all understand that it is really about resiliency and being able to respond to the climate. And as designers, we very much have a process that we all go through for how we do our design work. And over the years, and it's been 25 years for me working in this field of what I call basically sustainable design, I have developed a process that I would call site-specific and climate-driven. And those words and process that I look for in my projects talk about all the climate change things that Sierra was just talking about, and what I believe is my fiduciary responsibility to provide good knowledge, educate the people that I'm working with so that they can make the best decision possible as they see it appropriate for the environment that we are in today. So back to you, Sierra.
So, the good news is everybody on this call is probably an expert at form, right? We can design very beautiful homes that are a joy to live in and come home to and entertain in. And the challenge is that often when we're faced with needing to address climate issues, weather issues, increased code requirements for insulation, and what we anticipate coming, which is increased code responsibilities around durability, it can often be seen as a compromise. And one of the core principles of the design that we want to walk you through today was, what does it look like for a building scientist to build a house for himself, which is me. This is my personal home and a home that I'm designing for me and my family. What does it look like for a building scientist to partner with lead designers to combine the two aspects of form and function and to create a standard that doesn't compromise either? And so Stace and I have been talking for 2 years now in designing and permitting and iterating what we believe offers an inspiration and an opportunity to share the costs, the function, and the form of a home built to the highest sustainable standards, but also to a strict level of livability and design and an ability to have something that feels familiar and is available to consumers regardless of their personal perspectives. One of the things that I'm keenly aware of as a large production builder who builds coast to coast is, while I'm very sensitive to a lot of the building science and climate related issues that's happening, it is very important for us to inspire our consumers at the place they come from and enable them to live better regardless of their political or geoclimatic perspectives. And so the beginning of this story, because this is both a passion project of mine, but also my personal home, is I'm the little kid on the bottom right with the bowl haircut holding his mom's hand. This is me at my grandparents' house in Michigan growing up, and is kind of the place that created the most significant memories in my childhood for me. And when my grandparents passed, it was the first time that I thought that I would actually take and from a blank sheet of paper build something that meant something significant to me, that I recognized that not only was I very lucky to be in this industry, but I had an opportunity to start with something that reminded me of the way I grew up and how important the home and the function of the home was when I would visit my grandparents and shape these memories as a place to begin this thought experiment. And the thought experiment is, as a building scientist, and as I reached out to other people that I trust in the space, I constantly asked the same question, which is, what would you design for someone you love? And it really created a culture of collaboration and a sharing of expertise to handle the desire to have a very livable, functional home, but also to set a standard for health and for comfort and for functionality that enabled an average builder, which is my sphere of influence, and designer, which is Stace's sphere of influence, to take a big step forward into the potential and realizing the potential of what homes can be. And so, Stace, I'm going to walk a little bit through how you think about combining these two things in a way that exemplifies what your ethics and your beliefs are.
So I'm going to start from the real basics that I think as designers, we all know that indigenous design, which is the design work that was done by cultures through the century before they had air conditioning, heating, cooling, all those good things, before they had any kind of systems that could help them deal with the environment, is where the basis of this design starts and our understanding of design, right? And I think what CR and I both do really well is we both understand this indigenous design premise really, really well. And what we are able to do is add the building science that we've been able to add since we have systems that we can use to help us to enhance that living environment. And the challenge that CR and I regularly grapple with is, how do we keep it simple? How do we keep it cost effective? And how do we get people and other designers, other builders, subcontractors, and everyone to want to go down this path with us of building a better building, a more cost-effective building, and keep it simple. And for them want to make the change from them doing it the way they always do it. So what I've always tried to do in my own practice is try to figure out, how can we do this? How can we bring forth all of the knowledge and everything that we have, because we know as designers we get bombarded with information, and building and design has become much more complicated. It's much more specific to all different kinds of systems and this and that and the other thing. So again, what CR and I are trying to strive in this project is design a simple building that uses all the available building science and the systems that are readily available to anyone and everyone who is building a home, with the full understanding that with all the climate change going on and everything going on in our environment right now, everybody's concerned about safety, their security. Back to you,
Yeah,
Sarah.
and one of the things I want to underscore that you'll see elucidated as we go through the specifics of this home is that Stace is an expert in environmental design. I'm an expert in building science. And one of the things that we constantly, we have the discipline to remind ourselves is this is something that we are doing for the average consumer. And we had to constantly ensure that we weren't just speaking to an audience of early adopters or an audience of sophisticated buyers, that we ensured that this design represented something that we could bring to a 36-year-old mom focused on raising her family and providing for her family, and still could inspire that public to get more than they've been given by architects, engineers, and designers for the last 50 years. So, we have two general principles that help us remind us that is one, the thing that Stace does so well, which is the responsibility to be an expert and to provide for the quality of life of people that live in his designs. And as a company at Meritage Homes, we call that life built better. And the way we talk about to our sales teams is to make sure that we act as an expert, right? We don't expect the general public to be the expert, but that we provide that expertise and that support in a way that really enables people to get more than would be provided if they just went out in the market and were looking for location, square footage, and price point. So without further ado, I do want to kind of get into the details of this build, because there's some interesting things. When Stace talks about indigenous design, we should really talk about where this home is being built, because the challenge with this design is that we wanted to excel from the current building place, but we also are building it in a pretty good environment. And so, the beginning of this story is that if you look at the way conventional homes are built, and we'll get into this heavily on design, but the only reason that anybody would know that's a picture of an old building in the background is because there's a 1942 Plymouth parked in front of it. If there was a Tesla parked in front of it, nobody would have blinked. It's the same construction, the same angles, the same materials, and there's a strong need for our industry to exceed the past. There's a strong need for us all to challenge the status quo and to be those trusted experts who provide a new level of value for our consumers. And so as we walk through the design, underlaying all this design is once again the goal to inspire, the goal to create an easy recipe for a more sustainable built and a more functional environment than we've been able to provide. And in order to do that, we have a team that supports Stace and I in attempting this. We have one of the largest zero energy builders in the Pacific Northwest, Ted Clifton, and I am blessed to have a great relationship with Green Builder Media, who not only is running that microsite, but brings in a team of experts at each stage along the way in form and function, great engineers, and a whole list as a large production builder that I have the absolute joy to reach out and work with the designers of leading appliance companies and leading materials companies and leading fenestration companies to really look at what is some of the best things that they've got in their R&D facility, but also something that's very appropriate for the specific indigenous location in this design. And so I will let Stace introduce you to this little piece of forest outside of Seattle. Stace?
Thanks, CR. I also wanted to remind everybody that, as we all know, as interior designers, architects, designers, construction people, we all have access to these experts, and we all just need to go out and find those experts that we trust and believe in and work with well to create the same kind of team that CR and I have done to work on his project in Seattle. So you can go to the next slide. It's okay, CR. And just so create your own network. Figure out who it is you need to be a part of that team, and to that integrated process that we've heard the design community harping on for so long. So CR was fortunate enough to buy an outstanding piece of property, basically east of SeaTac. It sits up on top of a mountaintop, which is both fantastic because it gets some amazing views and has a beautiful chunk of forest, but it also is very challenging because it's the top of a mountain. Not that it is a big high mountain, but that it is very exposed to all the elements. So we get some big winds that come and go. We get sun coming from all the angles, so we get the full gambit of sun all day long when he actually has sun, because it is also Seattle that we're talking about. And we also get a lot of movement of water on the site from stormwater that comes down. So you can see from the topography that CR is showing, man, it's a pretty steep site, which again is a challenge that I think that we use to our advantage.
Yeah, for those of you who are looking at this on a small screen, the large center of the thumbprint is the house location, and the topographic lines show that it falls 700 feet in 3 of the 4 cardinal directions. One of the things that as we go through is a challenge, and therefore yet again an opportunity, is those steep slopes and the remoteness of this location. There is a 2-mile forest road in order to access this. There's some pretty steep roads in order to bring the equipment up to do this design. It provides breathtaking views of the Cascade Mountains. It is in the middle of a beautiful thousands of acres of federal forest, but it also provides a tremendous amount of challenge to work with municipalities to build something on a site that they're not used to permitting, with materials they're not used to seeing, and with trades that have to slug up and down this road and dig into this mountain in order to build something that design. But I will say this is the view from the back of the house, and It certainly, hopefully, it has inspired all of the designers that are working with Stace in order to execute this to make good with that view, but also to address the challenges that come howling up this mountain.
Yeah. I mean, you can see the beautiful view, but you can also see, boy, that's a steep site, right? So we know that in this area of the country, we're dealing with a lot of water, right? A lot of water that is in the atmosphere itself, falling on the site. And we know that who knows what kind of forest fires we may be dealing with in the future. And we know that we have earthquakes that can come through the area. So we have a lot of outside forces of the environment as it implies on how we work and design this project and the process that we went through. Very important to us was trying to integrate the building so that we could understand how the water movement on the site was working so that we could stay out of the drainage plain areas. We also worked through understanding any kind of natural animal trails on the site, things of that nature, so that we integrated the home not only to capture all the views and do everything that our client wanted from a design intent, but then we had to layer on top of that all the environmental issues that we have going on at this site, in this location, in this region, so that we could design a project that worked with all those things together. I'm sure it's hard for you to see this site, a little screen that you're possibly looking at, but know that we nestled this project into the site, working with the topography, keeping the driveway as short as possible, and trying to give us a good buffer zone for any kind of forest fires that may happen or something of that nature. Note that we also tried to keep anything downstream like septic and sewer connections, and it's a septic connection, not a sewer, but a septic is down, so it's gravity fed. We're trying to keep this as simple as possible, the least number of pumps, the least number of filters, all those kinds of things. As we started talking about the challenge of the environment that we were building, we noted a few important things. Number one, drilling through all the stone in the property for a lot of money per lineal foot. It had to be drilled to get water that may be there, and we didn't know how many hundreds of feet needed to go down to get to water. We determined that being a site-specific, because we get so much rainwater there, that we would have a large cistern that would provide all the potable water. As in any typical project in this day and age, everyone is worried about low utility costs. We don't buy water. We get it from the sky. It's free except for the pumps to run it and to build it. Everyone is worried about energy. So we have a very highly insulated envelope with SIPS roof, a structurally insulated panels roof. We have insulated concrete form walls, and we have insulation underneath all of the at-grade concrete slab so that we do not have any thermal bypass or very little thermal bypass going on, and a very highly insulated project. We also then responded to the exterior design of saying, gee, we're in the middle of the forest and Sierra's property is not near a fire station, so we want to be able to have a project that can withstand and be more durable to not only the moisture coming from the sky, but also any forest fires or things of that nature. So we have steel roofing, we have steel siding, we have stone siding. We basically have a non-combustible designed house. And in general, because we're so highly insulated, we have a well-ventilated house, and we'll go into that more in future slides. So you can see we're talking about a cabin, but we're talking about a modern twist on a traditional cabin look. And you can see from the image of this elevation here that you can see a serious amount of topography, all those steps to get up to the front door. But you can also see that we have nestled sit down in there. On the far right-hand side, you can see the carport, which is really a carport for our PV system. And you can see that we have an entryway that's a lot about light and bright and glass because, right, we don't get a whole lot of sunshine all the time in this location. You can see that it's metal siding and stone, a whole bunch of it. Here you can see a very preliminary design of our SketchUp model as we're putting this concept together. And again, you can just see that kind of glass entry feature that says indoor, outdoor. It also is very welcome and inviting. And I will also have you note, though, that on the right and left-hand sides of that image, you don't see windows in these locations. So we used windows fortuitously, I would say, so that we took advantage of the views that we wanted, but we just didn't put windows in to put windows in because, again, it's a lot of moisture, and we didn't need views in certain locations. So I'm going to describe floor plans very quickly just so we can all get a concept together in our minds of how did this design lay out. At a walk-off on the basement floor, which this is the floor above the basement, but in the basement we have a garage, we have a cistern, we have all of our mechanical. You go up to the main living level, which is at grade at the bottom of your screen and then falls off at the deck at the top, towards the top of your screen. On the main living level, we have living room, dining room, kitchen. You can see from CR's design that he really loves to entertain in the kitchen dining room area and likes to get big groups of people together. So the space in the living room, dining room area doesn't have a whole lot of windows because it's really about an intimate time to be together, entertain, and enjoy each other. But when you go into the living room area, you can see that we have a lot of glazing on both sides. It's the gable ends, it's big, huge views, and it's really about connecting to the great outdoors. When we go on the far left-hand side of your screen, that is a guest suite, and it is also CR's home office and library space. As we go up to the next level, these rooms are in the gables. So we have very steep pitched roofs in these areas, and it's why you can see all the functions of closets and things of that nature are on that steep pitched roof side, so that when we get to the middle in the bedroom is a nice high ridge, which allows the heat to get away from a human being and hit that ridge line. And you can see that we basically have two master suites and a big open area in the middle, which we'll get to. So again, this shows us the other side of the house. Also to note as designers, we've moved to pretty much using Revit for everything because we really like the way that we can integrate all the different systems into our drawing and design process. So we start designing, as you can see in the earlier images, from simple SketchUp models. We move from those simple SketchUp models into a 3D design where we can have a full conflict resolution to all the systems that we are putting in to the home so that we know that there is the least amount of conflicts or challenges during the building process. Again, this is the back porch, and this is the back porch early on in the design. It doesn't show all the topography changes and all those things, but you can see that we have a mixture of stone, steel siding, steel roof, and a steel gable end with a lot of glass. And that is capturing that amazing view that CR showed you earlier in that slide of his site. This is as the design is pushing through time, right? So when you saw where we started, here is more where we are ending up. You can see that the back porch got a lot bigger and it's covered more. So there's more use of that indoor-outdoor space. You can see that we're showing some concrete form work. That is the mechanical space. So underneath that deck is the actual mechanical space of the house. The grating that you can see, the louvered system in the corner of that deck, actually houses an atmospheric generator there, of which we'll talk about in the future. And you can see to the left that there is the PV trellis parking area, which provides all the power for the home. Again, simple, modern cabin. Sierra just integrated this piece to us here recently, and Sierra loves to barbecue, again, loves to get people together and hang out, and we decided to put a little dining pavilion a little ways away from the house where he can barbecue. The reason it's a little ways away from the house is to get that barbecue grill and smoke from traveling into the house, but being able to go to the side. And we're using this pavilion in between the house and the pavilion dining itself to create space in between the two. And the in-between space is the deck space, the fire pit, the congregating outdoor areas, and we're using the near and far exterior to create a feeling and an ambiance of space, because otherwise when you walk outside, all you do is see huge, long views. And sometimes we believe it's great to have some of those local views, intimate views, and intimate spaces to congregate.
You know, one of the things I love about this as Stace has evolved this design is that as these pieces come together, what's been happening is the house experience is slowly getting pulled and stretched into nature, right? The cascade of the decks, the remote dining location, the ability to have a forest that folds into a dining location, that folds into outdoor living and fire pits, that folds back into the outdoor deck, that folds back into this big glass exposure. It really does take a modest-sized home and expand it into these 25 acres of surrounding forest in a way that really makes it a very estate-sized live, but also really pulls the nature back in on the inside. And in this weather, when it's going to be, you know, rainy some days and foggy some days, but there's always this amazing experience of being in nature. I really love the design is grabbing nature and pulling it along with us.
So again, we're just going to look quickly at some elevations as we're moving in here. This is the side of the house. You're looking at the PV trellis. You've got the parking underneath for the cars. On the right-hand side, you have the louvers again for all the mechanical and atmospheric generator systems. And again, it's just supposed to be nice and simple, clean, elegant design. You will also notice in the floor plan is very rectilinear. Again, we're trying to keep it simple. We're working within the systems and the span of the systems, which is a Hambro flooring system with a concrete deck that really works to maximize the use of that product. And that's how we ended up with a lot of the widths, designs, and proportions of this house is how those systems are being used most efficiently. Again, just a little original rendering of that same elevation, you know. So here we get into the nitty-gritty of the design and a whole lot of the systems of this house. So you can see on the left-hand side, we actually have a 30,000-gallon plus cistern, providing all of Sierra's water needs for both domestic and landscape. We have a typical house with a two-car parking. We have a laundry room, which is in the middle towards the bottom of your screen, number 5 and 6. And then on the north side of your screen, number 9 and 10. Our number 9 is the atmospheric generator room, and also where all of our PV batteries and interfaces, our solar center. And number 10 is our mechanical room. And we'll talk more about those systems.
Yeah, I will give Stace the out. One of the only argument that he's lost in this entire design process was me putting a remote laundry system in, which is me being a super pragmatic building scientist. A dryer sucks out so much of your conditioned air when it runs. I really argued to develop a space where I could put the laundry system outside of the conditioned envelope to reduce the negative impact of laundry. And it's unconventional, but it's also super convenient, right? It's easy access. It's a big room that provides storage of laundry and clean clothes and easy access to the rest of the house. But it's probably one of the more unique locations for a laundry. And I wanted to make sure blame landed where blame should be, which is on the pragmatic building scientist, not poor Stace.
No, oh, poor Wooey Stace. Also note, if anybody is interested and wants to know how to offset that dryer problem of losing and having bad air changes per hour, email me. I'm happy to tell you how we do it in other projects.
So I wanted to tee up Stace a little on the interior as we go to some of the interior renderings, because one of the two design principles that was important to me as the person who's going to live in this home was, what was the home built around? And in that climate and the way that I live, I wanted a heart to the house. And almost dead center in this home is this amazing 13-foot wide, 26-foot tall stone monolith with a fireplace set in it, to really act as the center to collect community, the center to start design, and the center of the aesthetics of the home. And so as you kind of walk through the interior design, this is really based on my strong desire to create this big stone monolith as the centerpiece for the home and the heart of the home. So as you can see, Stace had walked you through the floor plan, and before we get to the renderings, you can see it, the thing labeled as number 15 is that fireplace. Right, as you come in, it's the big stone monolith to your right. As you're sitting there, it envelops your views on either side of nature, and it really does provide the center of the home around which all of the traffic swirls and the guests would turn, and the lifestyle of the home is largely based around that. And the second piece was, whenever I've loved a cabin, I've loved lofts. I've always loved that, rustic cabin with a loft up in the apex of the roof. And it's just not something that you see in conventional design. But it's a feeling that I really love, that you go upstairs and you get nestled into the attic, and it feels to me warm and secure. And as a scientist, I love the origami of all those roof lines coming together. And it really did those two factors, the large stone monolith and the master bedrooms seated up in the attic, were really kind of the two big asks that I made of Stace as we came in and thought about the way this home was going to live and the way it's going to feel.
So important to note also that as Sierra feels as this is the heart of his home, in his own being and heart, it is also the heart of the home as part of our heating and cooling system, that we have this highly insulated envelope, but we also have thermal mass throughout the entire project. All the floors are Herro system with a concrete with a radiant floor heating in it, but this mass in the middle of the house is what we're using to de-stratify the home, and what we're using to heat and cool during the appropriate times of the year. And we'll talk about that in some later diagrams. So this literally is the heart of our heating and cooling in our indigenous design also. Again, you can see great views indoors, outdoors in this space, this amazing fireplace and central design element with the steel coming into it, and everything is kind of an awesome modern cabin.
So as we transition kind of up into these, the second aspect, which that was so important to me, which was the bedrooms in the attic. There's two things, hopefully you'll note in the renderings. Is one is the really interesting geometry available when you utilize attic space, and two, pragmatically, this is a relatively small footprint house, right? It's 25 feet wide, it's 75 feet long. And so it would provide a relatively modest floor space, But by using the attic space in this way, by tucking these two dual masters upstairs, we get to a large amount of usable square footage, significantly more than is offered by a design of similar without leveraging your attic. But more importantly, it gives you these really interesting walkways and partitions and, bedrooms with closets nestled in the drop of the ceiling. But these Gothic tall 12 pitch roof ceilings that with SIPs free span. And so you've got these really great open spaces. And one of the interesting things that you'll catch is these designs, because they're up in the attic, we wanted them to be permeable. We wanted that central window area to have access and allow air movement and allow some diffuse sound movement to really connect all these spaces into the home. And so we've designed some really interesting elements to pull spaces back and forth and to create interesting transitions. Stace?
Yes, and CR, not everybody would live this way, but I love what you've done, because you look at this, you look as a home as a building science and how the whole home works together. And I think it's fabulous. The way that light's going to move through the project, the way that air is going to move to come and not have a big change in temperature throughout different times of the day or different times of the year, I think it's fantastic, because it really goes down to the basic principles of design and having the whole home work together. And I think we better keep going. There we go. So here is a very simple diagram where we're looking at that chimney, and we're looking how this chimney is the heart of the home for its heating and cooling. So again, we don't have a big need for cooling in this environment, and we don't actually have a huge need for heating either. But we decided to go with what everyone really loves, is a heating system that is radiant floor, great feeling on the feet, right? And also very, very efficient. And basically what we're trying to show in this diagram is that, as we all know, heat rises. And so during the colder times of the year, all that heat rises. We collect all that heat at the apex of the ridge of that second floor, and we take all of that heat and we put it back into that chimney with simple little fans that run for about 8 cents a day. We put that heat back into that chimney, force it down the chimney, and back down through the bottom of the floor, so that we have a continuous loop where we're collecting all that hot air above, suck it in the chimney, and redistribute it throughout the home. This allows all the mass that we have in the floors and in that chimney to continually recharge themselves in the winter. In the warmer times of the year, we grab the cooler air from the outside and we supercool that chimney so that we can cool the mass during the warmer times of the year. So mass works for us both climates. Go ahead, Sarah. Thanks.
Yeah, so Stace had mentioned this a bunch, but I just wanted to put my building scientist spin on it. This house sits on top of a 700-foot grade change in its basalt, which is a volcanic, very hard rock, and so therefore groundwater may be found somewhere 900 feet below this home by drilling through basalt, and it really was financially unfeasible. But also, it afforded us the opportunity to rethink the way we think about what an off-grid zero-energy cabin could look like. And because Seattle gets 90 inches of annual rainfall, we were able to design this house around water capture. And so I love the look of steel roofing. And so we reached out and found this new product from Boral, which is a stone-coated steel roofing. Which design-wise is super great. Energy efficient-wise, it acts as a cool roof, but also acts as a nice surface to collect all the water that hits the roof into downspouts that then actually pre-filter and go into that cistern that's a part of the foundation. And in doing that, we exceed the water demand by almost 2 times of an average family of 4 just by the water that comes and hits that roof. And so we should have a tremendous amount of opportunity to provide all the water for this house off that roof. And then as we'll walk through, there's another additional system that enables us to actually take humidity out of the air and create distilled water from the humidity to augment the water demand should it be necessary, and have 35,000 gallons of storage capacity to both serve the water needs and actually to flex some of the excess energy that could come off these solar panels in mild climates. And so
again, I'm just going to butt in for a minute there, Sierra. So again, we work with people all the time as designers, right? And you tell them, let's do an off-the-grid home with the cistern and collecting roof water, and everyone's all really into it. But the big challenge or fear that they have is, well, what happens if it doesn't rain? And the atmospheric generator is a very simple piece of equipment. It costs about $2,500, and it works just like a heat pump. And what it does is allow CR, when he needs to make like 100 gallons of water a day. So super simple system, easy to maintain, and it gives everyone that feeling of security. Go ahead, Sarah.
So I'll take a little bit of this. You know, Stace talked a lot about, hey, we want to use thermal mass to increase comfort and to leverage the climate, right? There's during the summer, it's a very cool 60 degrees on this hill, but it'll heat up to the mid-80s during the day. And by using thermal mass, we can ventilate the home, bring that cool air in at night, cool down that large thermal mass, which is the interstitial space of that masonry system in the middle of the house, and use that to maintain very, very cool temperatures during the day without running an air conditioning system. It's the way homes worked before the invention of air conditioning. And these shifts, not only do they provide for a new opportunity to reduce energy efficiency and allow us to be off-grid more effectively, it's actually one of the largest design elements that's going to start impacting all of us going forward, because this load shift, or what they're referring to now as grid optimization, literally impacts the cost of producing energy for residential power use by $1 trillion. And so there's a tremendous amount of research being done by the US EPA and the US Department of Energy and policy that's being created that we will see code coming out through the IECC that requires us as designers and builders to start considering load factors, the way a home consumes energy at peak, and using strategies like thermal mass, like ventilation, like controlled fenestration, to start really thinking about load management and shifting those peak loads off of the utility demand curve.
As designers, all of us are going to be so involved in this in the future, it's not funny, at trying to help all of our local jurisdictions understand how do we all play a part in doing this. It's part of us as designers providing information to our owners and our clients so they can make educated decisions. Go ahead, CR.
So the other piece of not just being really efficient is enabling us to generate a project that demonstrates very smart zero energy. So there is actually access to power, but we decided that because of the push to a low carbon energy source, because of the push for homes to become zero energy in a lot of municipalities, we wanted to have the discipline to not tie into grid power. And so this entire home is self-sustaining from water, and it's self-sustaining from power. So we designed the PV system as an architectural feature, that rain shed off the front of the garage that acts as a carport, and an architectural feature to the tuck under garage. But also we wanted to tie that energy in with a good, intelligently designed home. So, you know, that lower left picture of a barn with solar, right? You can make any home, including a barn, zero energy by not thinking through the details. But by using SIP roofs, by using high thermal mass insulated concrete forms, by using efficient appliances. And by using storage, we can tie the entire home together to have a very low demand, a very flat energy curve, and actually demonstrate a project that is appropriate to tie into utilities to provide that load flattening, low demand residential structure in places where they either don't have sufficient roof space to tie into the grid, or they don't want to depend on batteries and they want to use the utility to augment their power demands. And so all of this comes together in some very interesting ways to tie in the materials we're using for durability, the materials we're using for comfort, and the materials we're using for zero energy to create a program that is very synergistic, that load shifts, that uses smart controls, and ultimately ties together to take all of the peaks out of a home. And we'll be monitoring this for the next several years, circuit by circuit, and reporting it back through Green Builder Media and other partners in order to demonstrate a design standard that achieves these future goals of load optimization and grid optimization. Stace, any thoughts on this before we move along?
I think we should move along just because we're going to run out of time, and I want to respond on one of these next comments, on the next slides. So
as we kind of wrap up the thoughts about this, there is a tremendous amount of embedded technology, right? There is a solar system, there's a battery system, there is a radiant floor system, there's a ventilation system that can do both health and passive cooling. There is a condensing system to create water. There is a cistern that you need to be able to monitor to know how much potable water you have. There's pumps to run both the radiant flooring system and the cistern system. There's the hot water system. There's the lighting system. And all of that could be complex and easy as a building scientist to run, but not something that I would build and provide to an average 36-year-old mom and expect her to be happy with the control system. So one of the big opportunities we've had is to partner with companies like Control4 to integrate all of this building scientist and all these algorithms and all this complexity into a system that is super easy for an average consumer to use through a single dashboard.
This is what I'm absolutely most excited about, CR, in this project. And the reason being is I've done lots of vision projects over the years across the country with Green Builder magazine, but you are the first owner that understands that collecting this data, and we understand as building scientists how things work, but we're going to be collecting real empirical data, which I'm absolutely so excited about. And we're going to be able to help develop this dashboard that's going to make this process easy for anyone who can run a smartphone. Basically will be able to control and understand what's going on in their own house. And I think that is absolutely the future, and we need it now as soon as we can get it, so that we can all understand how we as individual homeowners can plug in to overall goals that are developed either by our local governments or our own environmental goals where we want to be a part. And so super excited about this.
Right. As Stace has constantly referenced, the intention of this project and the reason we're having a webinar like this for it is that, you know, it is a passion project of mine. It's obviously a passion of Stace's. But we're also doing it in order to provide resources and tools for the industry. So we will continue to work with trades, work with suppliers, work with municipalities to help develop an easy recipe book. And we'll be sharing out costs and designs and results over several years through this project that we really hope creates inspiration, but more importantly, creates easy to follow guidelines in multiple climate zones to take a lot of this building scientist and optimize all the projects that each of you are working on, right? Whether it's just cost-benefit optimization, if it's proof of concept, I mean, we're definitely leveraging some off-the-shelf materials in unique ways, but also we want to build tools to make it very plug-and-play to control, very plug-and-play to permit, a very plug-and-play to model the energy efficiencies of, to get this done in different municipalities, so that it isn't just a one-off passion project, but a easily accessible, usable tool for architects and designers to improve and inspire their clients to get more than a conventional home has provided them all these years. Stace, final thoughts?
Sorry, I was on mute there. CR, again, I think I'm going to end with just saying how excited I am at being fortunate enough to work on a project like this. Thanks to our sponsor for giving us the ability to reach out and talk with everyone. And I think CR and I are interested in answering any kind of questions that anyone may have, and you know, being able to connect you into seeing the progress of this project.
All right, we have used an hour of your time. I hope everybody is staying healthy out there. I hope that this project further provides tools and assets to our industry that I love, for us to be successful, for us to build amazing residences and spaces, and more importantly, helps all of you be successful in your jobs. So thank you very much.
Hey guys, thank you so much, CR and Stace. I do have a couple questions. Do you have time for a few?
I do.
Okay, perfect. So we're going to go back to the cistern. How do they keep the water in the cistern fresh? Does it have to be chlorinated? Is the first water in, the first water out, so it continuously recycles? How does that work?
Yeah, it's two things. Is one, there is some pre-course filters coming off the roof. So the twigs and the bugs and the things that would normally contaminate a cistern are pre-filtered. So all you're going to get is rainwater and particulate in the cistern, and that ages very well. And you actually want that to not have a lot of biological activity, but a little bit, because it actually stabilizes the water quality of the cistern. And then the water is pulled out of a combined source just in time and treated to potable standards. So the potable water is treated last second before consumption through a series of advanced filters and UV treatment, so that it's as fresh and serviceable as potable at the last minute. The other good piece about the cistern is, in this climate, we get twice as much water as we anticipate use, and we're augmenting water from the atmospheric generator. And so the system is designed to overflow and then go into the downstream forest. So the groundwater is, every water that hits the roof eventually goes back into the ground that it would have hit without the house there. But it also turns the water over at a relatively good rate, and continues to have that entire system not have an excessive amount of biological activity. There's also the cistern's partitioned into two pieces, so it can be isolated, and fine sediment that settles in the bottom can be removed without completely eliminating the source of water for the house.
Okay, great answer. And that kind of answers another one here. So I'm going to go right to the floor plan that you showed much earlier when it had all the different numbers on it. Someone was asking, what is number 14? And is there a reason the kitchen exhaust is not between the windows to vent out to number 14?
You know, I can talk about the ventilation before you get to 14 very easily. So we are using one of the new Panasonic systems that's rolled out into the marketplace called Cosmos. They've been beta testing it for about a year, and the Cosmos system is a balanced ventilation system. And it works combining together kitchen and bathroom exhausts and using those with some fresh air intakes called Panasonic Freshes that we're using for supercooling during the summer, or bringing in the ASHRAE required amount of fresh air into the home because we're making such a tight envelope. So this type of a system actually combines all of the exhausts in together, and you don't see them coming out the kitchen exhaust in between the windows because we're taking it up through the wall and out the eave just so we don't have to see that exhaust. But again, that exhaust system is all interwoven together as a balanced system, extracting air and bringing fresh air in as needed to meet ASHRAE, and is going to be tied into the dashboard that CR and I were talking about earlier, so you can see how it's functioning. And the Cosmos system has scenes, like Lutron lighting has scenes, right? Well, your Cosmos ventilation system will also have scenes. The really cool part about this system is that it has a FUBOT that will tell you if you have high VOC contents in your air, and it will automatically turn on. They have sensors that they're deploying soon that will be able to tell is their allergen pollen levels are high outside, don't bring in fresh air. Smoke outside, don't bring in fresh air. So it's really about indoor air quality and ventilation, all combined in with the ASHRAE side for the energy. So it's a really cool system, and again, very simple and very cost effective.
Okay. And let me directly answer the question. So, this is definitely a builder who designed his own home. All the tall appliances are along what would be considered the east wall of the house. So the refrigerator and the range hood are just above that number 10 across from the island. And so the direct exhaust off that range hood will come directly out of that wall and not between the windows. So all the tall appliances are along that wall with the upper cabinets, and explains why there's not a lot of fenestration there. The fenestration is off to the right towards that number 14, giving you a look up the access road and up towards the peak of the mountain. And that is all open space. And that number 14 is the top of the solar array that is between the ground floor and the underground parking location. So you're seeing basically the very top of that solar array, which we've designed to also be a rain shed over the parking and the access to the garage.
Okay. So since we're looking at this particular picture right now, I have someone that's asking, he or she is a custom cabinet designer. What type of cabinets do you feel would fit best into this style home?
I will tell you, I've had a passion project to find old steel style stamped cabinets because this is stained concrete floor and stone tops, and I would love the kind of enamel painted steel. But I am actually currently looking to kind of think about the finishes of that kitchen. So tell that designer to reach out to Stace and I because we're looking for inspiration on that.
Okay. And then someone, since again we're looking at this, someone was asking about the bedroom partitions that you showed. They said they were lovely, but they wanted to know if they allowed for electrical and outlets, cables, etc. And if so, looks like a very private space with good sound and visuals.
Yeah, so they absolutely will. We are still kicking around what that partition would look like. Stace has sourced some really cool 6 and 8 inch barn wood, and we may do kind of a gapped barn wood surface, which would allow us to still on the vertical support members bring up conduited electrical and mount TVs and mount electrical on those walls, so we can still have appliance services and things hung on that wall. But instead of it being a solid surface, drywall or anything like that, the intention is to allow some air and some light to filter through that wall basket weave style. But whether it's going to be vertical rods or horizontal barn wood, we're kicking that around. So once again, anybody with a brilliant porous thought about that wall, reach out to Stace and I because we're trying to figure that out as we speak.
Okay. So someone's asking about how do you see a home like this working in a place like Houston, Texas, for example?
I'll let Stace answer the details, but from my point as a building scientist, I think that the wrap of the house, the aesthetics, you would want. So you'd probably do a little bit more brick, and you'd probably do some more things architecturally to tie it into the Houston feel. But as far as function goes, Stace can answer for me. As far as function goes, this would work really, really well, right? It's very well insulated. It's got high performance windows. It would provide for beautiful views, right? And the energy efficiency and the durability of this house would be very, very appropriate. The only thing is in that climate, you would be adding some air conditioning compressors to augment the ventilation to manage the heat gain in those climates during the summer. Stace, what do you think about this design? It's appropriate.
Sierra, I think you totally hit that nail on the head right there, that because this is a highly insulated, good thermal mass interior design, it's going to transition to any climate zone. Your window spec is going to change, and as you said, you're going to need a cooling system that specifically takes moisture out of the air, so has a dehumidification component to it. And this design is a good indigenous design that should be able to transition to any climate zone in the United States of America with slight modifications.
Okay. So since we're talking about that, so someone asked a question about retrofitting existing homes with some of the things that you've described in this custom home. Do you have any thoughts on that without it costing a fortune?
I have a ton of thoughts. I'm spoiled to be able to design from a blank sheet of paper, but I always recognize that these projects should enable retrofit. So the things that we learn by building them, when there's opportunities to do better air sealing, which is a big component in retrofit, when there's opportunities to add radiant barriers in the attics very cost effectively, there's a lot of good tools where as HVAC systems fail or as appliances are replaced, that these what used to be fringe high-performance appliances, by creating economies of scale, come into the marketplace at a much lower price point. But the fresh air system, the home automation systems, all of those are very, very plug and play, and we're excited to share them out as much for retrofit as they will be appropriate for new.
Okay, and then since we're almost out of time, I just want to give you guys one more question, and then I have a comment. So someone's asking about the exterior. Why did you choose stone-coated steel roofing for water collection? I know there are differing opinions on which roofing materials produces the best quality water, and wondering what your thoughts are.
Yeah, so I first started with steel because in a rainy environment, there's something really beautiful about the sound of rain on a steel roof. And then as we evolved towards the design, it was clear that we'd have an awful lot of smooth steel surfaces in the board and batten walls above the stone. And so creating some texture was an excellent opportunity. And then when we ran into this Boral stone-coated steel, as a building scientist, I noted that it stood off the roof, which means there's an inherent air vent underneath this steel roof. An inherent air vent means that you put the roof in shade and air can move up between the steel and the underlayment of the roof to cool the roof so you don't have super high heat gain in these summers. And because we're just using passive cooling, it enabled me to do those three great things. It enabled me to have the noise. It enabled me to have a aesthetically appealing surface that blended well with the smooth board and batten steel that was going to be below it. And it enabled a really good energy efficiency in the way that steel piece is designed, that it doesn't directly lay on the roof and doesn't directly transmit radiant energy into the system.
Okay, great. So I know a lot
I
of
would
people...
add one more piece into that. The other reason it also is that it's the area we don't have to collect every drop of water also. So it's going to be different in different zones, like Houston or someplace like called New Mexico or Arizona. You're going to have a slick coated roof to try to get every bit of water you can get.
Standing seam would make a lot more sense than arid. Yep.
Exactly. So we didn't have that kind of a worry. We had too much water.
Okay. So I know that a lot of people have been asking for your contact information. I'll certainly supply that to everyone so everyone out there knows that. I just wanted to let you know that we have a design teacher that's been watching today, and she's very anxious to use today's recording for her students who would have missed this incredible webinar. She's going to share it with them, and she plans to discuss it after watching this as a class.
That is high praise indeed.
Awesome.
Yeah. So I want to thank both you, CR, and Stace for this wonderful presentation today, and your time, your expertise, and to all of you out there for attending. Have a wonderful day.
Cheers.